Now for assignment 1.04 number 2, we are multiplying and dividing rational expressions. We are beyond the basic level we had before, and we are just in our normal level. Assignment 3 will be the advanced level that we see down here. So, Curti and Boulan were each asked to perform the following operation, and their responses are shown below. So, are either of these students correct? So what we're looking for is whether or not there are any cancellations that they have exploited or made use of while they are doing their work. So we have to decide, are either or both of them correct? If you are really stumped in this on a test situation, you could always graph the three of these as y1, y2, and y3 in your calculator and check to see which, if any, of y2 and y3 match y1. In this case, we're going for a more elegant solution that works in the real world when you don't have multiple choice options in front of you. We start by copying it over to our whiteboard. And now we are going to factor out any common factors we possibly can. Our first numerator has a common factor of 3, while our first denominator has a common factor of 2. So with this, we can cancel our x plus 3's. Yes, even though it's laggy, that was a plus 3. But those are the only common factors. So 3x plus 2 over 2x is an equivalent form for this expression. So we do not see the equivalent of 3x plus 2 over 2x. That would be 3x plus 6 over 2x. So that's not the 3x plus 9 that Curti had. So Curti is incorrect. Boulan is incorrect because that x plus 3 cancels. It is not squared. Boulan appears to have divided instead of multiplied. Neither student is correct. Now, this one, again, is going to take a little more work as we are going through and doing our simplifications. Then we have to check which values of y make the resulting expression undefined. So we will have to keep track of where we have division by 0 before our factors cancel. After is easy to track. It's still important, but we have to remember if anything cancels, that's still undefined. One way to evaluate that is by going through these one at a time and substituting these into our denominators. For example, y equals 0 gives us a negative 35 times a 44, so that one is perfectly well defined. If we let y equal 1, our first denominator becomes 0, so that can't be it. If we let y equal negative 1, they both appear okay. And then the negative 7, the 11 over 2, those will take a little more work to check. The negative 11 over 2 actually is the same as a negative 44 plus 44, so that is one of them. And I suspect the y equals negative 7 is there because this appears to be a factor here, but with a common factor of 5, that may cancel out. So we will do this out explicitly and see what we have left over. So now we have transcribed the question over here. Let's start by pulling out any common factors that we can find in our two numerators and denominators. So our first numerator is already a monomial. There's not much we could do with that. But our second one does have a factor of 5. It gives us a y squared plus 6y minus 7. In our second numerator, we do have a common factor of 2y, leaving us with y squared plus 15y plus 56, and a denominator with a common factor of 4. leaving us with a 2y plus 11. Now our 5's can cancel. Our 2 can reduce with the 4. We have another 2. And now we can start factoring even further. The y squared plus 6y minus 7 becomes y minus 1 times y plus 7. And here we have a 2y plus 11. So this does mean that 1, negative 7, and negative 11 over 2 are all non-permissible values. So we can add our negative 7. So we have these 3 non-permissible values already. We just need to complete our simplifications. In our numerator, we have a y squared and a y for a y cubed. And this y squared plus 15y plus 56 factors to y plus 7 times y plus 8. Which means our y plus 7 is a removable discontinuity. It's still a discontinuity, but it can be removed, which means it's not going to produce a vertical asymptote. So it will make the expression undefined, but it will not produce a vertical asymptote. So that leaves our final expression as y cubed times y plus 8 over 2 times y minus 1, 2y plus 11, which we just need to transcribe over to our Khan Academy answers. So I pause the video to do that transcription to save a little time. And now we have a division problem. So which values of k will make the resulting expression undefined? Here it matters where k was ever in a denominator. So that's our 18k to the 6 we already have, which triggers at k equals 0. This 12k squared minus 24k, well, that is going to work at k is plus or minus 2. If k were negative 2, we could get some sign changes here after factoring out that k. No, that would just be plus 2. Never mind. We are also going to have to worry about any place our numerator in the second term equals 0, because that is about to become a new denominator. So k squared minus 37k minus 38 factors to k minus 38 times k plus 1. So k minus 38 gives us a root at k equals 38, and the k plus 1 gives us a root at k equals negative 1. So it looks like k equals 1 might be the only value that's okay here out of everything on this list. So our last step is to do our simplification, which again we will do on the whiteboard. Our first step is always to transcribe the question. Then we're going to reciprocate our second fraction, because dividing by a fraction is the same as multiplying by the reciprocal. And now that we have this, we can start factoring our numerator and denominator. In this first stage of factoring, I have just pulled out common denominators or common factors where I can. That's that common monomial factor, and then that's only that second denominator that has been fully factored. Now I will finish factoring our first numerator. And I do understand that these steps are just appearing very quickly. You can always pause a YouTube video, but you can't always speed up a class. So if this particular question is making sense, it doesn't take as much time to go through it. We can now start our cancellations. The k plus 1 cancels. We have a simplification with our 12 and our 18 with a common factor of 6. We have 3 k's that we can cancel. So that becomes a 3. And then we collect our like terms. And, first I correct this. 6 is what we pulled out. The 3 is what we have left. Now we collect our like terms. And after these simplifications, we are left with 2k minus 1, k minus 2 over 3k cubed times k minus 38. This is the answer that we transcribe into Khan Academy. And this is what we submit. Now, our final question. With this, are either of these students correct? Well, looking at this, when we do that division, our term on the right reciprocates. We are going to have a 4n over the 8n minus 6 here, and the n plus 1. The 4 and 8n minus 6 have a common factor of 2 that cancels. So it appears Camille's is correct. There are no further cancellations possible, so Naledi cannot be correct. Her answer is different. So Camille is correct, but Naledi is not. And this wraps up assignment 1.04, number 3.